Thank you folks for joining us today. My name is Alex Huidish. I'm a networking specialist solutions architect with AWS, and I'm joined on stage by Sridhar Kulkarni. He's the product manager on the EC2 networking team. And we are going to be talking today about the feature that we launched yesterday, Cloud WAN service insertion. Sridhar is going to tell us a bit more about what the feature is and how it can help you, and we're going to look at architecture and migration patterns. But before we begin, some housekeeping items to make sure that you folks are all aligned. So this is a 200-level session, but we will look at route tables and we will look at traffic flows and traffic patterns. So just keep that in mind. We will let you know when animations are complete. We do love animations, and the folks in the audience here, I see a lot of familiar faces. You folks know that about us already. We'll let you know when they complete. So if you want to snap photos, we know that everyone loves doing that. We do that as well. You will be able to do that at that time. And watch out for the networking wizard. It's going to give you really good tips whenever there are architectures that we are not covering or options that you have. Follow the wizard on the slides. And that's it. Let's jump right in, Sridhar.
Sure. So before we get into this details about the feature, we are going to go through some context setting, and we're going to talk about Cloud WAN for folks who don't know about Cloud WAN. So just to set up a context a little bit, as the data centers and apps are moving from remote sites into AWS, we see two very strong and very common networking trends. One is a lot of the customers are asking us, how can we use the AWS backbone to the fullest to solve my WAN connectivity needs? And then the second thing is, a lot of these customers are also asking, well, how can I use AWS as a hub for networking? Right? So a lot of the customers have hubs in data centers and remote sites and colos and whatnot. But as the compute gravity shifts to AWS, they want to use AWS now as a networking hub as well. And the sophisticated networking technologies that we offer in AWS certainly helps with that. And one of our innovations in this arena is AWS Cloud WAN. So Cloud WAN is a managed WAN service that we offer that lets you build global networks in a matter of minutes, right? And the whole idea is to leverage that AWS backbone to the fullest, not just to interconnect the VPCs in a region, across a region, but also to interconnect your remote sites, your data centers and offices, using the AWS backbone essentially to each other. So build like a global unified network. The other thing about Cloud WAN is, it simplifies the networking aspect of it. So it abstracts a lot of the networking complexity away from you, gives you a centralized policy framework. You specify your intent in that framework, execute the policy, and under the hood, we build the network for you, right? So that's really a very important pillar. Segmentation, so security and networking always go hand in hand, and segmentation is a first-class feature within Cloud WAN, right? And then finally, monitoring and visibility, a key investment area for us. We have a lot of dashboards, events, alerts, all of that good stuff at your disposal. And it makes it super easy for you to manage and monitor the networks using these tools that we provide. So let's look into a little bit on what are the main critical components of Cloud WAN, right? So we have 5 main components that let you build these global segmented networks, using Cloud WAN. Now let's look at each of these components a little bit. So it all starts with a core network. So core network is the AWS managed network, which is part of your global network, which is managed by AWS on your behalf. The core network has a set of core network edges. So think about them as regional connection points. We spin them up for you in each of the regions where your Cloud WAN network is. And then you do, and these core network edges are fully meshed. They talk eBGP, so all routes are dynamically exchanged across the regions. And you get any-to-any connectivity essentially. It's a fully routed network. And then you can bring in your attachments into these core network edges. Now, one of the hallmarks of this service is, as I said, like segmentation is a first-class citizen within Cloud WAN. So essentially you can just specify in your Cloud WAN policy or in a UX, practically with a single click, you can build global segments, which are isolated, independent routing domains. And then, these segments, you can also localize them to regions, because there are a lot of use cases around data residency as an example, where you may want a segment to be contained in one or two regions. So you can do that as well. Now, the heart of Cloud WAN it starts with this core network policy. This is where you specify your intent. So you're going to say stuff like, here's my ASN ranges for my routing. Here's my edge locations, the regions that I want to build my network into. You're going to define your attachment policy. Now, attachment policy is something which gives you a lot of automation in order to onboard these different attachments, like VPCs or VPNs or whatnot, onto a segment, right? So with a simple tagging framework, you can say, hey, these VPCs with a tag of production, onboard them onto a prod segment. You specify your intent here, and then once you execute that policy, then dynamically, those attachments can onboard onto a segment. You can put the tags on the actual attachments at any point in time, and they will onboard onto the correct segment. Okay? So there are different attachment types that we support with Cloud WAN. It starts obviously with VPC. Then we have some specialized purpose-built attachments for the software-defined WAN use case, SD-WAN use cases, like Connect attachments. There are two flavors of Connect attachments. There is the GRE-based flavor, which gives you 5 gig per tunnel sort of bandwidth, and then you can have 4 tunnels per attachment, 20 gig per attachment bandwidth, and you can interconnect any SD-WAN appliance with Cloud WAN, right? And then you have the tunnel-less flavor, where based on your feedback, we have again given another innovation where you don't need any encapsulation, right? You can just go plain old native BGP peering, and that's how you connect your SD-WAN appliances to Cloud WAN. And then you have attachment for peering transit gateways, right? So this is for a lot of our customers who have networks that are built on transit gateway, and we want to make sure those networks can be integrated seamlessly with Cloud WAN. And so that's where you will use the transit gateway route table attachments. And you can extend your segmentation strategies across both those services. You can peer a segment with a route table, and that's why it's called a transit gateway route table attachments, which essentially sits on top of a peering connection between transit gateway and Cloud WAN, right? And then finally, site-to-site VPN. So this is a native IPsec tunnel that you can directly terminate on Cloud WAN. So here, we're just showing an example of how VPCs attach to these segments. So the idea is the attachment tag, as I mentioned on the VPC attachment, determines the propagation, right? So the VPC siders get propagated to the segment route tables the moment you do this, moment it gets attached to the segment, and then you can route traffic from a VPC to any other point in the network. Now these attachments by definition are multi-AZ, so you can drop your Cloud WAN ENIs in different AZs. And that gives you a highly HA, highly available, highly resilient sort of an architecture when it comes to VPC connectivity. Now, inside the VPC, you have to configure the routes, the destination routes, with the target as core network. Now, this is very important. This gives you the flexibility to determine which traffic you want to route via Cloud WAN versus which traffic maybe you want to just locally route via an IGW inside a VPC. So the propagation, this is a very critical point, which for understanding, is the propagation from the VPC siders to the segment is automatic, but this is one place where you have to go in and populate those siders in the VPC route tables, because that gives you that much flexibility, right, to determine how you want to route packets out of that VPC. So you can have distributed routing patterns, and also at the same time centralized routing patterns. From the VPC, both are supported, right? And then the next is the Connect attachment, which I was talking about. So this is a purpose-built SD-WAN attachment. It uses a VPC attachment as for transport, and it essentially, once you have a VPC attachment as a transport, a Connect attachment as an overlay, then you can configure peers on top of these BGP peers on top of this connect attachment, right? And you can do that to interconnect two SD-WAN appliances in a HA pair, and each of those SD-WAN appliances can act as a BGP peer. Right? Similarly, as I talked about with this innovation, with tunnelless connect, the original connect attachment had GRE encapsulation. With tunnelless, there is no encapsulation. It's essentially straight, direct, native BGP peering between the SD-WAN appliance and Cloud WAN, right? And then the only thing that you have to do is, in the VPC route table, you configure the routes for the Cloud WAN inside siders, right? That's for the routing protocol to work essentially for the BGP peers to talk to each other. So that's an anatomy of how a connect attachment and a tunnelless connect attachment works. Right? Now, for transit gateway peering, you have a peering connection between a transit gateway and a core network edge. Right? That's your base connection. And on top of that, we overlay that with the route table attachments, right? So this is where the end-to-end segmentation story is pretty critical, because now you can peer an individual transit gateway route table with a segment in Cloud WAN, right? And then this route table attachment is also supports full BGP-based dynamic routing. All right, now inspection architectures. Alex, you want to go through this?
Awesome. Well, so we are talking about security these 3 days, right? Security is job zero at AWS, and is job zero for you folks as well. So with Cloud WAN, some of the most commonly deployed architectures are inspection architectures. And there's two flavors of these. There's centralized egress, egress-ingress inspection, where all the environments in Cloud WAN segments get this inspection integrated. And there's cross-segment inspection. And until yesterday, actually, the way in which you could achieve this integration of your either third-party appliances through Gateway Load Balancer or AWS Network Firewall was by creating regional inspection segments and associating inspection VPCs in each region. And for centralized ingress, you would have to configure static routes in those inspection segments, and those static routes would be the ones that would take your traffic to the egress inspection VPCs. So if you look at the traffic flows, these would match the routes that you would add in the route tables as static routes, right? Cross-segment was also something that you had to manually configure. A lot of you folks I mentioned that I'm seeing familiar faces. You folks have this architecture deployed, and we're going to look at migration patterns from this. But those static routes had to be there to ensure reachability and symmetry between regions. So for centralized VPC to VPC inspection in the same segment or across segments, the traffic within a region would be inspected locally by the appliances in your VPC in that region, and cross-region would be double inspected. So you would have to have the inspection configured so that symmetry is maintained across regions by inspecting both in the source region and in the destination region. Right. Return traffic would also work. But we've listened to your feedback, right, Sridhar?
Absolutely, and we heard your feedback loud and clear, as Alex mentioned, and we launched a new feature yesterday, which is the AWS Cloud WAN service insertion. And this feature simplifies your centralized inspection architecture. So a lot of the details that Alex was showing you in the previous slides in terms of like regional inspection segments and all those static routes in those workload segments, we have removed all of that complexity away from you. And we are going back to our first principles, where you specify your intent in your policy, like how do you want to inspect, and execute that policy, and we will do the routing under the hood for you to make that inspection happen, right? So that's what this feature is all about. It's single-click insertion of AWS Network Firewall or any third-party inspection appliances within your traffic paths, within your global traffic paths in a Cloud WAN network, right? So it's a huge feature, and it goes a long way in terms of facilitating your compliance and your inspection goals for your global AWS network. All right, so with this feature, we have introduced a new component called network function group. So let's look at what a network function group is. So think about it as a container that points to all your firewall and security appliances, or that infrastructure, right? So it contains all your inspection VPC attachments, as an example, as part of it. And it's a global construct, and it consumes one Cloud WAN segment under the hood, right? So this is a managed segment on your behalf in order to in order to hold the routes that are necessary to do the steering to these security appliances, right? So routing in that segment is fully managed for you. There's no need for any static routes in the workload segment or in the inspection segments. All of that goes away, and we automatically propagate these routes to the network function group. And then you have full visibility. Now, it's not a black box. Just because we are managing the routing on your behalf doesn't mean that you don't get to see what's in there. So you can use APIs in order to see how we are doing the next top redirects, what are those routes pointing to, where are the inspection VPCs, and so on and so forth, right? So you have full visibility into the NFG as a construct. Now, let's look into how it works a little bit into more detail, right? Like, how would you set it up? So there's three very simple steps, right? So the first step is you create the network function group. It's a named reference, and you'll just say, okay, here's my network function group 1. You're going to say, whether you require attachment acceptance or true or false, meaning whether you want automatic onboarding of the attachment on the NFG, or whether you want it to be like a workflow based where the network admin blesses that attachment before it gets onboarded, right? So this is a very same concept that we use in our attachments today when they get onboarded onto segments. No difference. We are reusing that same construct for network function group as well. So you define your NFG, and then you update your attachments to associate themselves with NFGs, right? So all your firewall inspection VPCs where your firewalls are, to that attachments you can attach simple tags like, hey, my key is environment, my value of the tag is NFG1, and your action is going to be add that to the network function group 1, right? So it's again a simple policy statement to associate your attachments to the network function group. And then after you attach the tags, and then this is the important piece, right? So this is where you specify what your inspection intent is. So one of the popular use cases is centralized internet egress and ingress, right? A lot of customers set that internet egress VPC up. So this is a very popular matrix-based approach that we use with our customers. So you can just simply say, hey, my production and dev segments, I want centralized egress from those segments. And my shared services, hybrid, and third-party segments, I don't care about internet egress. I don't want those segments to be part of my centralized egress architecture, right? Like that's how you would define your intent. And then you define your policy based on that intent, right? So you would say we have a new action clause, which is a send to clause. The send to clause is designed for internet egress use case, right? So you will say, hey, segment development action send to, and just point it to that network function group that you just created, right? And you can do that for each of your segments. Like in this example, we are doing this with dev segment and prod segment. And once you do that, this is like a regional NFG attachment, right? So as long as you have a regional attachment inside a region, that is what's going to be preferred. A local attachment for egress is always preferred. That's what the traffic routing path will take. Right? And then you can also configure like different NFGs for different segments. So if we support multiple network function groups, it doesn't have to be a common one. You can use different NFGs for this use case as well. And then once you sort of like execute that policy, then this is how the route propagations would work, right? So we configure a propagate like a default route, 0/0 route to your production and dev segments, right, as it shows in this slide. And then we propagate all the automatic routes to the network function group in order to do that routing back to these workload VPCs. Right? So we do all the routing setup for you, and that's how the routing works. And now within a VPC, again, I'm going to go back to the same point. This is something that you have to configure. So you can configure like a 0/0 route to go to core network for that centralized internet egress ingress. But then you also have the flexibility to configure some other route to do distributed egress ingress via the IGW inside that VPC. So again, the flexibility is super critical for us, and so you have that provision to do that inside the VPC. All right? And so the default routes that you see again here are all automatically generated by Cloud WAN. So you don't have to configure any of these static routes yourselves. It's all automatically handled for you. All right, so let's look at the traffic path. So traffic originating from VPC A, step number 1, it's going to hit the production segment. It looks at the 0/0 rule. It's going to exit out of the inspection VPC in region 1 through the network firewall. And then the traffic coming back in is going to hit the network function group, which has got the routes back to, which are pointing to the VPCA. So the return traffic is going to go back to VPCA. Now, same thing in region 2 again, you are going to have the same traffic pattern through the inspection VPC of the region 2, right? Because it's always the localized inspection VPC that's preferred. And then the return traffic back again is going to hit the network function group in that region and then go back to the workload VPC C, right? So that's how the traffic pattern looks like. Now, what happens, you might ask, like if the NFG does not have an attachment in the region, then how does this work? In that case, Cloud WAN is going to automatically select an egress region based on a certain default priority. And we have published what that priority list is for the regions in our documentation, and then that's what it's going to follow. However, you can also override that default priority, right? So we are giving you a lot of flexibility here. You can choose the egress for each region as well. So there is a new with edge overrides clause as shown in this policy. You can use that clause to say, hey, for my edge, for my region US West 2, use US East 1 as the centralized egress, right? And so you can configure that and you can prioritize that region for centralized egress. All right, so now one of the other popular use cases is cross-segment inspection. And Alex is going to walk us through that.
Awesome, thank you. So, centralized egress, we've configured that. You have the routes and the route tables and the segments, and the NFG has its routes. We didn't show actually on the slides the NFG routes. You can see those either through the GUI in the console or through API calls. We tried not to put a lot of routes on those route tables. So you have full visibility, but they're also fully managed. Now, a lot of you folks may be familiar with this kind of matrix approach of putting segments and the relationship between segments in Cloud WAN in a very clear intent-based statement. So it's all about intent, right? It's all about defining the types of segments that you have and how you want those segments to communicate with each other. You will hear us actually talk about east-west inspection as well. It's not about east and west as regions, but horizontal communication between VPCs in different segments. So once you define your intent, right, you put that policy together, you express this intent into the Cloud WAN policy. And here, Sridhar talked about the send to action, which allows you to essentially insert in, or Cloud WAN to insert in your route tables the default route, both in IPv4 and IPv6. The second action is send via, right? So send via means that between the two segments that you define, or any pair of segments, for example, here we have production and development. You can also have a list of segments. For example, when production talks to development in shared services and hybrid, that traffic needs to be inspected. So this all reflects into the policy. Now, what the action is for that send via is the network function group that you define and you specify in the policy. So we've created here network function group 1, and we're saying, well, traffic between production and development needs to go through network function group 1. Now, very important. I mentioned that the way we used to do that inspection, right, through the static routes that you folks have configured or would configure on those inspection segments, was to do double inspection, right? So both in the source region and the destination region, so dual hop inspection. We've heard your feedback, right? And the default action here is single hop. This means that for any region pair, right, the second dimension into inspection, not just between segment prod and segment div, but also when that traffic crosses regions, right? We've added the capability for you to specify if you want to inspect that traffic only in one of the regions, or if you want to inspect it in both. So single hop is by default that approach to inspection in just one of the regions. Now, very important, again, Sridhar mentioned the region priorities. We have a list of default priorities defined, but if you do not like those default priorities, you can change that, and we'll see that in a second. Now, the route tables here have a bit of a different view, a more in-depth view, because they are actually regional, right? So a segment is a global construct, but your core network edges are regional constructs, right? And they will have route tables for that segment in each region. So we'll see that this is the way in which we are able to maintain that symmetry, right? Whenever we're routing traffic. So what service insertion does for segment-to-segment communication is that it inserts these routes in green that you see on the diagram automatically into the production and development segments based on the policy, setting their next hop as the inspection attachments that you have in the network function group, right? So here we see that, for example, one of the two attachments was chosen, the one in region 1, and routes are maintained symmetrical. Let's look at traffic flows, right? So I'm really I'm sure that you folks are curious of like how is this traffic going to flow and how is it going to be maintained symmetrical. So first, let's say VPC A wants to talk to VPC B intra-region cross-segment, right? So inside the same region, but between production and development. That traffic matches the route in orange, so the route that was propagated through service insertion, and goes into the inspection VPC. Now, once the traffic is inspected there, routing in the inspection VPC still has to be set, so you have to make sure that that traffic can return back to Cloud WAN. The traffic returns into the network function group, and the network function group has all the routes it needs to ensure that that traffic can go back to the segment that was initially intended for, right? So we're inspecting traffic cross regions, but intra-region, but cross them. Now, as Sridhar mentioned, also for centralized egress, right? We keep region affinity, and this is the best practice. We don't want to create cross-region dependencies, right? So traffic cross-segment, but in region 2, for example, will choose the attachment in that region. If there is no attachment, then again, region priorities will be the ones that are going to be used, and then you will be able to configure those and override the default priorities. Now, I mentioned the single hop. It is the default approach to the send via action, but you can absolutely do the dual hop one, and we're going to see how the policy looks like. Now, cross-region, cross-segment. This is the one that the traffic flow used to be double inspected, both in the source and in the destination. So let's look at how traffic flows. Because we insert the right routes into the right route tables, and we set next hops for those routes to make sure we maintain symmetry, the traffic is actually going to be inspected in one single region, right? So because region 1 was the one that was by default chosen based on the priorities, inspection VPC in region 1 is the one that inspects that traffic. Now, the return traffic is maintained symmetrical, right? So there's an intrinsic need for, whenever you're integrating firewalls, that firewalls see the originating flow and the return flow, and this is ensured using the service inserted routes in your route tables and in the network function group. Now, I mentioned that this is automatically maintained, so our wizard does emphasize on that. And you can do also dual hop. We do have customers who have the use case for inspecting in both the source region and in the destination region. It does come with the need to maintain firewalls and firewall rules that match the traffic both in the source and in the destination region. But regulatory compliance needs do dictate it. So you can absolutely configure this as well. The important thing here is we see that we have network function group 2. The reason for that is because you can use a network function group only in either in a single hop mode or dual hop mode in the policy. That is how we are able to maintain route symmetry. Right? Now, I mentioned that if you do not agree with the default region priorities, you can configure edge overrides. So what this means is that whenever traffic goes between production and development, right, as segments that are global, the region dimension is controlled by you. So whenever, for example, here traffic goes between US East 1 and US West 1, right, you define the region pairs. The edge location that is going to be used for inspection is going to be US East 1. You can also define here lists. So you can say whenever US East 1 talks to these other 5 regions, right, inspection has to be done in US East 1. So it simplifies your policy a lot by creating those lists. You can also say, well, I really like defining on a per region pair basis exactly for each of the region pairs. So you can do that as well. And really important, this is a use case that we've seen a lot of customers adopt for highly regulated type workloads, for example, PCI compliance, where traffic between VPCs inside the same segment has to also be inspected, right? So this leads to the creation of isolated segments in Cloud WAN. And for those isolated segments, you can have all the traffic be inspected by using the send to action, which we've attributed to the centralized egress, but this actually gives you also VPC to VPC inspection within the same segment, right? Now, a few considerations around service insertion and the network function groups. I bet that all of you folks have asked yourselves, well, can I also have not just VPC attachments, right? Can I have my route tables attachments on Transit Gateway, for example, be part of the network function group? Yes, you can. So can I have my connect attachments, right? Where I have my SD-WAN implementation, perhaps, be these next hops for the routes that are inserted in the route tables? The answer is yes, you can. Really important, the default route is the one that is honored. So you saw that we insert in the segments 0/0 or colon/0 in IPv6. So the dynamically routed attachments need to advertise these routes, right? You can have multiple network function groups, and this is really important because you may have different firewall rules for each, and you may have different policies for each. And as we go back to that matrix, right, where we define the intent and we sit down and we're saying, okay, this is our production environment and this is our development environment, or any number of segments that you folks define, you can specify for each of those, right, what your intent in terms of inspection is, and also where that inspection should be configured, right? One network function group can be used for insertion within a segment pair. This is really important. If you would have more than one, we wouldn't know, well, who actually needs to do inspection, right? So it makes sense to have one network function group between production and development, for example, right? You can't have two. But you can, for example, between production and development, have one network function group, and between production and stage, have another network function group, right? Just if you have different firewall rules. And as I previously mentioned, a network function group cannot be used in both single hop and dual hop modes, so you will have to have different network function groups. Now that we've gone through how it works, right, and what is the feature and how you can apply it in greenfield environments, I am sure that you folks are really, really curious to know, well, I started with Cloud WAN 2 years ago, right? I already have my inspection in Cloud WAN, or I have my inspection on Transit Gateway. How do I get to Cloud WAN, right? So we're going to talk about both of those use cases. And our first one is existing environments on AWS Cloud WAN, where you folks have those inspection segments that you manage and all the static routes. Step 0. It's going to be a step-by-step approach, right? So we're going to review each step. The first is, what do we have in our existing environment? Really important here, we do have both centralized egress and segment-to-segment inspection in this example. You don't have to have both. There's also multiple ways of doing the migration. We are looking at just one of the routing configurations. So if your environment does not look exactly as the one that we have here on the screen, that doesn't mean it's not supported. It is fully supported, and we've tested a lot of scenarios, common scenarios that our customers have, and we can work with you on defining your own migration path, right? Now, first things first, what do we need to do? Create a network function group, right? So we define the policy. Recommended is to start with attachment acceptance set to false. The reason for that is because you wouldn't have to go through an additional step of accepting the attachment for the network function group as you're migrating. You can go afterwards and you can say, okay, I've migrated, everything is good. I validated traffic flows. Now I'm going to set the attachment acceptance to true so that not everyone can actually attach their VPCs to this network function group, and it's a fully controlled environment. This is a policy change. Depends also on how you do your policies in Cloud WAN and how incremental you treat them. But to actually create the network function group, you will have to apply the policy. And this doesn't lead to any route changes, actually. It just creates your network function group, so no impact to traffic flows. Step number 2, create the attachment policy for the network function group. Right? So we define, okay, what are the tags that are expected by Cloud WAN for attachments into the network function group. And you can, again, apply the change set, or you can just do one policy change for creating the network function group and the attachment policy. It's up to you. And again, there's going to be no route change. The third one is creating the service insertion policy. It's essentially saying, okay, how I'm going to use this network function group that I just created. And we've defined here a centralized egress for both production and development, so it's the same use case as earlier. Once you apply this change set, there's not going to be any change to your routing. And then we go and we say, okay, this is our centralized east-west or VPC to VPC segment-to-segment inspection. And once you define this policy, we've mentioned already that you can deploy dual hop inspection as well as single hop. And once you apply this change set, you will have to go and change the attachment policies for your inspection, attachment tags for your inspection VPCs. So your inspection VPCs are at this stage attached to your inspection segments, the ones that you create and you manage. And once you change the tag, the inspection VPCs are going to be moved towards the network function group, right? And here is where your routes will change, right? So if we look at the routes view, you will see that based on that policy, right, that you defined for centralized egress and for cross-segment inspection, your routes are going to be updated into the route tables. Really important here, one thing to notice is the default route, both in V4 and V6, it shows it's static. It's not a static route that you configure. It's a route that we've configured as part of service insertion, right? So it is an inserted route, but it's still a static route. Also, traffic symmetry is maintained, same as we've seen in the how it works session. Now, let's look at traffic flows. As we've seen before, the routes are matched in the segments, the routes that were inserted using service insertion. So traffic will be maintained symmetrical for prod egress, for dev egress within the same region, and across regions, right? So centralized egress is localized to each of the regions, and that is the default behavior. Now, for cross-segment and intra-region, again, routing is going to be maintained symmetrical. We've reviewed this traffic flow, right? But it's important to know how it works in the migration scenario. And as this traffic flow is maintained symmetrical by using the routes in the route tables and the routes in the NFGs, your inspection segments are no longer going to be used. Right? So they are just sitting there. You see that they're grayed out. The traffic never gets to those segments, right? Now, cross-region is, at this point, again, maintained, symmetrical, and it uses a single inspection point. That one that was defined in the policy, no longer double inspection. Now, very important, you will clean up the existing inspection segments. You no longer need them. They no longer have any attachments, right? So as you clean them up, it will be a policy change, but it will not be a route change. Very important as well. You can also go into from your existing environment into dual hop inspection first. And then you can say, well, I want to migrate to single hop. It's all up to you, and you have full flexibility into how you configure this, right? So very important. Now, this is Cloud WAN migration to service insertion, right? How do we treat the existing environments, right, with inspection on Transit Gateway? Well, here, if we start using the same process, right? And we look at the existing configuration. The existing configuration here is actually has some considerations that all of you who are using it today are familiar with. The first one is, as we have our setup for both centralized egress, right, on Transit Gateway and for cross-region inspection, all traffic across regions is inspected, right? Even if it comes from production to production across regions or from production to development, because of that peering route table where all the routes or all the traffic gets in, everything is inspected cross-region. Now, with Cloud WAN and with service insertion, you will be able to migrate off of that. Traffic that is within a segment will no longer have to be inspected, right? So we'll see how that works in a second. Now, the setup is for both centralized ingress and egress. There's a lot of variations of how you, our customers, are implementing this today. We have customers who have not multiple route tables on the same transit gateway, but separate transit gateways. So that can also be achieved. Sridhar mentioned about the route table attachments, and we're going to see how you can use them for either a single transit gateway with multiple route tables or multiple transit gateways, one with a dedicated route table for each environment. Also, we will look at one approach to doing this migration, right? Depending on your operational model and depending on your automation, and depending on what you've built around Transit Gateway, you can approach this from multiple angles, and we can work together with you. We'll have some reference points. We are going to publish really soon a migration blog as well. But again, as I mentioned a bit earlier in the Cloud WAN migration piece, if your architecture doesn't look exactly as the one we're presenting, it doesn't mean that it's not supported. It is fully supported. So let's see what our steps are for migration. So first thing is we create the Cloud WAN core network without any segments. Here, again, you see variation. You could create it with segments. It's fine. Nothing changes, right? And you peer the transit gateways. Here, if you have transit gateways, one per environment, for example, that's also fine. You can peer multiple transit gateways to a core network. So as we peer the transit gateways, we create that transport path, right, between the Cloud WAN core network edge and the transit gateway, onto which we will later on create the route table attachments, right? Now, this leads to no route change, right? Really important. It's just the logical construct that was created. Now, the recommendation is to create a new a network function group and new inspection VPCs. These new inspection VPCs will have the separate infrastructure, will have gateway load balancer endpoints, or will have network firewall endpoints. And really important, what this gives you is the flexibility of doing a really easy rollback in case you discover traffic flows that don't match your expected intent, right? Because as we'll see through the steps, you will be keeping the existing configuration in place, and we will go delete it and clean it up after we've validated that the entire migration was successful. So, creating a new network function group, creating the new inspection VPCs with the endpoints in them, and attaching those to the network function group. This is no policy change, no route change, everything is located on Cloud WAN. Now, the really important piece is that you can also attach your existing VPCs to the network function group. But as Sridhar was mentioning, then the VPC routing is the one that will matter. The VPC will be attached to both Transit Gateway and Cloud WAN, which is totally possible, by the way, right? And from the VPC routing perspective, you will have to control what traffic goes through Cloud WAN and what traffic goes to TGW. So that will involve route changes on your side. And if you're able to, I mentioned that level of automation and your orchestration that you have today, that is going to determine if you are good to go with this option, or if you're going to create new inspection VPCs. Now, step 3, create segments on Cloud WAN. You could have done this in step 1 as well when you created Cloud WAN. It's not a hard dependency. We've just taken it in smaller and more granular steps from the migration perspective. This is a policy change, but it's not a route change. Nothing happens. Step number 4, create Transit Gateway route table attachments. In this step, there's no policy change, but routes will change. And the reason for that is because when you're creating the route table attachments from Transit Gateway to Cloud WAN, all prefixes that the Transit Gateway has are going to be automatically propagated to Cloud WAN core network. And within the Cloud WAN core network, between core network edges and all the way through the other Transit Gateways that you have in your environment. Now, really, really important, a note here, hopefully the AS numbers that you choose for Cloud WAN and Transit Gateway are not overlapping, and you do not have issues with accepting routes on Transit Gateways from other Transit Gateways that have the same autonomous system number. So that is really, really, really important when you're selecting your core network edge autonomous system numbers. make sure you don't have them overlapped with anything that you have in your environment, right? So once you've created these route table attachments, routing within the same segment is going to be backhauled through the Cloud WAN core network. So traffic within the same segment is no longer going to be inspected, which is really, really important. You're going to offload a lot of that cross-region, for example, production or cross-region development inspection. And let's see traffic flows, right? So traffic flows for intra-segment are going to go through Cloud WAN, and traffic is no longer going to be inspected, which is the desired state, actually. In the end, the idea is traffic within a segment, unless that segment is isolated, should not actually be inspected. It is a routed segment, and everyone should have reachability with everyone else. Now, let's see how cross-segment intra-region traffic is inspected. It will continue to be on the Transit Gateway. So very important, traffic is not taken through Cloud WAN. It remains local on the Transit Gateway. And cross-region, cross-segment traffic is also, is also inspected on Transit Gateway, and it is double inspected, right? So both in the source region and in the destination region at this stage. Perfect. Now, return traffic is maintained symmetrical, so it will still be inspected on both source and destination regions on the Transit Gateway. Now, last step, or step 5 actually, not the last one, create the service insertion policy. So here's where you say, well, for my production and development, I keep that same matrix, right? And I want to have traffic centralized send to. Also, I will add later the send via piece. Again, you don't have to implement both, right? You can say, well, my policy currently says I just want to use send to. I don't want to do the send via piece. Perfect. Or my policy says I just want to do send via and I don't want to do the send to piece. That's also fine. We're just looking at an example. So this is the send via piece. You can do it in the same policy version change, or you can add a new policy version if you want to. And this will lead to route changes, right? Very important. The routes are going to be updated into your route tables and into your segments. So now Transit Gateways will learn those propagated routes from Cloud WAN, right? Those green routes on the diagram. They will learn and they will take the traffic egress towards Cloud WAN. Let's look at the traffic flow. So the static routes that you had configured on your Transit Gateway need to be removed, because they will actually be replaced by the routes received from Cloud WAN for service insertion. So once you remove your static routes, the static routes from the core network that we inserted for service insertion are going to be propagated into the Transit Gateway. So at this point, Transit Gateway says, okay, traffic intra-segment or intra-route table production or development is going to go through Cloud WAN. Traffic that needs to also be inspected cross-segment, it also goes through Cloud WAN, right? So all the traffic is matched by Cloud WAN, and inspection happens on the new inspection VPCs, right? The principles are the same in terms of defining your region pairs, your region priorities. The Transit Gateway just acts as a route reflector that sends traffic to the core network, and the core network makes the routing decisions. So our last step is clean up Transit Gateway route tables and peering connections and the overhead configuration that was there, and keep route tables. If you have separate route tables on the Transit Gateway or separate Transit Gateways, this will look exactly the same, right? You will still have the same configuration. And let's look at traffic flows, the last traffic flows that we're going to review today. Traffic within or cross-region, cross-segment that is probably the one that everyone is most interested in, goes through the inspection VPC that was chosen based either on region priorities or your edge overrides, right? And is maintained symmetrical, really, really important, right? So when traffic comes back, it is directed to the same network function group attachment and is inspected and sent back to the actual VPC that originated it, right? So really important. And last step here could be an optional step, could be a step that you take. You can choose to keep your transit gateways and to keep your attachments on transit gateways, or you could choose to move those attachments onto Cloud WAN. There's also a lot of other scenarios and configurations of networks where, for example, egress is on premises, right? And you folks will want to accommodate for that. That's also possible. The route table attachment is going to be that network function group attachment, and routing on the transit gateway will dictate how that traffic goes through Direct Connect. SD-WAN as well, we did not dive deeper into that one, but it is also possible as long as that default route is inserted, and for segment-to-segment communication, everything is fully managed by Cloud WAN. Now, we have a really rich partner ecosystem. So Sridhar, do you want to share a bit more about that?
So we just have a last couple of slides to close onto this. But as Alex mentioned, this solution works with both AWS Network Firewall and also the third-party security appliances. And we are very thankful and appreciative of all our partners who joined us in this launch. So it's always great to solve the common customer problems together, and we love that. And here's the QR code for Cloud WAN service insertion. Please take advantage of this. There's a lot of good resources in terms of documentation, blogs, and whatnot. And it will really help you deploy the solution. And then finally, I want to say thank you for listening, and hope you found this useful. And if you have any questions, we will be here on the side. So thank you so much.
If you folks have questions, we'll meet in the back, and we have awesome stickers for you folks. Thank you.